Okay, let's dive in. Uh, Today's topic is the agentic future of the enterprise, based on your book, uh, Eric and Davis, uh, called Agentic Mesh. I have a long list of questions that I want to ask you. First of all, welcome. It's a pleasure to have you. And Davis, I think the first question is one I would like to ask you. And Eric, you can obviously chip in if you feel like it, but we're discussing the agentic future of the enterprise. So why not start with a brief definition of what an agent is? How does it work? What is it in your words, Davis?
All right. Well, an agent is a software actor that can interpret context, pursue a goal, choose actions, execute work through tools, APIs, interact with data, and interact with people and other agents. The core feature here is agency. It doesn't just generate an answer, but it decides what to do next. It carries state across steps and adjusts based on the outcomes of prior steps. In enterprise use, an agent should be treated as an operational entity with identity, permissions, policies, and observable behavior. That makes it more like a model call or chatbot, and it becomes a governed software participant that can perform bounded work inside a business environment.
Oh, cool.
Yeah. Let me just add a little bit to that. Fantastic answer, Davis. There's two types of agents that I'd like to bring to the discussion. One is coding agents, which I'm sure if folks have been using Claude Code or Codex, they probably recognize the fact that they have changed software engineering and they are moving into the data engineering space as well as the business domain space. And we see things like OpenClaw, tremendous innovations. But here's the difference, and this is we're getting into our enterprise discussion, is these are personal agents. These are ones that run under your ID, your role, your permissions. You give them access to your environment, you give them access to your resources. Enterprise agents that we're going to talk about a little bit more are different. They're operational entities, as Davis kind of highlighted. They have identity, permissions, policies, and observable behavior. Now, here's the thing is these agents are now governed software participants in the enterprise, just like any other enterprise application. And that's the key difference, I think, just to lay the groundwork for how people have perhaps heard things about Claude Code and agents and such, and where we see the environment actually going.
Yeah, thank you, Eric. Thank you for specifying this. And I guess obviously that the participants here have a bit of knowledge in the topic already, or at least are interested, right? So we can get slightly technical here, of course, but some of the questions that I have prepared are also like um, more high level nature, so that we can get a thorough understanding of the topic altogether. And I want to open with the premise of your book, actually. Um, now that we are into the weeds, like you have written a book, and obviously the question is for both of you, so feel free to chip in, both of you, as you want. But I want to open with a little bit of a challenge, and I guess perhaps it's an easy one. You chose to write a book on what you call the agentic mesh. Why didn't you choose to write a book on what you could provocatively call the agentic monolith? Why is it a mesh? Why isn't it a monolith?
Sure, that's a great question. I'm going to bring up a few quotes from industry leaders. Andy Jassy, CEO of Amazon, said there's going to be 1 million agents in every enterprise. Satya Nadella with Microsoft has said that agents will replace software as a service. Jensen Huang has said, CEO of NVIDIA, has said there will be thousands, if not tens or hundreds of thousands of agents in every single enterprise. So what we do know is even if they're vastly incorrect and there's only 1,000 or maybe 10,000 agents in an enterprise, there's very few software entities in any enterprise that have 10,000 of anything. So we've perhaps seen something close to that in managing microservices. And the reason that a mesh comes into play is if you need to manage 100, 1,000, 10,000, or maybe a million of anything, you need to think of a different architecture. A monolith would just not be practical. Managing a million agents in a monolith would probably not be deployable on any meaningful modern architecture today. But if I distribute them, I have a chance. And quite honestly, the distributed architecture is what we see every single day, whether you're using cloud or even within data centers, you see thousands of nodes out there. So we think the most logical architecture for agents is a federated model, and the mesh, one where by definition any agent can collaborate with any other agent, leads itself to a mesh-based architecture just out of practical necessity, Ole.
Yeah, no, very fair. I think like this is just a personal observation, but in the very early days of Chat GPT 3.5, I think there was this idea that that the future of AI would be some would and this is going to sound awfully untechnical, but that the future of AI would somehow be very big chunks of software performing something simply because of the term large language model and the idea that that would somehow translate into some kind of monolithic architecture. But I do agree that what we're seeing is a very widespread understanding that agentic architectures must exist in what you can call a mesh, in the sense that you will have a very, very big number of agents that work together in a mesh. In your book, in Agentic Mesh, you distinguish between three type of agents, if you will, or three ways of working with AI in the company. It's what you call the AI workflows, autonomous agents, and enterprise-grade agents. Actually, in your definition, Davis, in the beginning of the conversation, um, you you already alluded a little bit to this. If you feel like it, I would want to expand a little bit on your definition and ask, okay, what's the difference between AI workflows, autonomous agents, and enterprise-grade agents?
All right. So that is a great question to ask, and it really gets to some of the differences that AI has been going through in the past few years. So an AI workflow is a system where the LLM and its tools are proceeding along a predefined code path. This means an AI workflow has to have every step it could take, every decision point, laid out in advance by whoever's creating it. Like you might be using an LLM at step 4 or step 3 to summarize something or to extract a bit of information or to classify something, but fundamentally every step in that process
Mhm.
has been defined in advance. Like the AI can only summarize, it can only extract if you've already reached that step. It can't influence the next steps very much. It's
Yeah,
basically fixed, and everything has, like, if anything unexpected shows up that the designer of the workflow didn't see in advance, you're just going to get an error, even in
yeah,
cases where it might be obvious to a human what the correct path is. Contrast this with an autonomous agent. Like an agent can dynamically determine its own execution path. If it has the tools available, even in an unexpected situation, it can apply them and work past the unexpected to figure out a new way to continue proceeding forward. It can recognize and implement new solutions on demand to deal with changing conditions. The adaptability and dynamic planning is really what sets it apart. And then beyond that to enterprise grade agents, It is the way that you integrate an autonomous agent into the enterprise to ensure that it is discoverable, that it is secure, that it is trusted, and all the other things that are going to be needed to truly make an enterprise accept agents.
Oh yeah, okay. So I see the difference clearer. Obviously, I I read the book in advance in preparation for this webinar. I also served as a technical reviewer. I didn't say that in the beginning. I don't think I said that in the beginning, but what I am convinced about is that this kind of thinking and the way you describe this will become your book will become a go-to source in understanding the agentic architectures that are possible to create in the enterprise, exactly because of these kinds of distinctions. And perhaps like turning the mic a little bit to you, Eric, in terms of um, in terms of in terms of the organizational reality and the enterprise, um, we tend to think of agents as something where one human represents one agent. Now, you very clearly show that in an organizational setting, you cannot really think like that. The distinction is, or the comparison has to be a little different. And so you have some metaphors that you use to translate the enterprise reality. So you translate. So let me just read the question to not make it too complicated for the listeners here. How do you translate a team and an organization to groups of agents? What's the fleet metaphor about, and what's the ecosystem metaphor about? Can you expand a little bit on that, Eric?
Yeah, absolutely. So we use this analogy in the book where we start with a person is like an agent. And as Davis mentioned, an agent can come up with a task plan, can make decisions just like a person. We extend that analogy into teams. So just as people work in teams and they collaborate with each other and they use tools, we call teams of agents, we call them fleets. Now, like people and like any organization, any modest size or even large organization, you have many teams and many layers of organizations, and they may be organized in a variety of different ways. Loosely speaking, we call that a company, a firm, if you will. In our agent terminology, we call it an ecosystem or the agentic mesh. Now, the interesting thing about it is we actually extend that analogy into supply chains, for example, where you have multiple organizations that have specific contracts that define how they interact, who they can collaborate with, what are the service level expectations or even quality expectations. So the analogy actually goes all the way into modern day manufacturing supply chains, for example, that have all these things that I mentioned, but these are exactly the same things that we would be able to apply to agents. And we actually think they would be applied to, this may be a new term, agentic process automation to make it distinct from regular business process automation or robotic process automation. We think the analogy of person to agent, team to fleet, organization to ecosystem, and then process automation is actually the right analogy, and probably the most intuitive one because, like you, like all of us, we all interact with other people. We work in teams typically. We work within a company organization, and sometimes we even interact with multiple companies. The analogy makes a ton of sense, and that's why we actually used it extensively in the book.
Yeah, no, agreed. I also think that um, like the level of coordination obviously increases the more agents you have, right? A fleet is something that you're capable of giving one direction with relative ease and say you all go in this direction under these conditions, right? Whereas an ecosystem becomes obviously increasingly difficult as you scale it to coordinate and give direction, and it shouldn't go in the same direction, right? If you have an ecosystem of agents, obviously what you're aiming at is a multitude of different processes that are not connected or only very loosely connected, right? So that gives you a completely different level of complexity to operate with. And I think what is very needed in the conversation around agents is that it tends to stop typically at the agent human comparison, whereas you really need something else than a human to compare a set of agents, right?
Hmm.
So I like that question. I like um, that that distinction you're making in the book quite a lot. Okay, so we're also prepared. This is a big one, and there are many different aspects in it, and I guess you can both answer it. You have both revealed parts of the answer, but I hope we can go into depth about it. But this is a big question, so I'll read it out, and then we'll chunk it up because no one will be able to remember it anyway. Um, yeah, so enterprise grade agents have 7 characteristics. So these are the enterprise grade agents. So we're beyond the autonomous agent here. We're into the to an enterprise grade agent, right? The most refined of its kind. Enterprise grade agents have 7 characteristics: security, reliability, explainability, scalability, discoverability, observability, and operability. And no one can remember that without repetition. But can you describe what these 7 characteristics in total makes an enterprise grade agent be like? And I think we should go through them one by one. So what's the security aspect of an enterprise grade agent?
Yeah, so Davis, I know you wrote the security chapter in the book. Why don't you start with your perspective on security?
All right. So, in order for an enterprise to accept an agent in their operations, they need to know that this agent is secure. It doesn't really matter how good work the agent's doing if, like, a random person on the internet can go in and delete your database. So, it needs to have basically, it needs to have permissions, it needs to have identity, it needs to be in your OAuth system so you can set what it has access to and what it does not. It needs to be communicating via secure protocols. You need to ensure that all your communications are encrypted. You need to ensure that nobody can just see what the agent is doing who isn't supposed to. Nobody can tell the agent what to do that isn't supposed to. And the agent isn't looking at or accessing things it shouldn't be able to in order to do its job. If you can,
Well,
if
It's
you can
kind
do
of
all
kind of
that.
Yeah, it's kind of interesting, Davis. It sounds to me, and this is something we're probably going to come back to, and this is something we've said in the book or in other venues also, is an enterprise agent is just like any other enterprise application that has an identity, it has roles, permissions, communication is secure. So that's the other thing that I mentioned. We're talking about something that sounds very new in some respects. It actually is not. In fact, the model we used in the book is that security for an agent should mirror the same level of security, although there are obviously some differences, but it should mirror the same principles and the same ideas as any other important enterprise application. Ole.
Okay, yeah, no, that makes a lot of sense. Um, and obviously, that also makes it pretty complicated. um, okay, but yes, obviously you need that, but you would also need, I guess. Anyway, perhaps get back to that because you would also need some kind of um, auto architecture created around that security, right? Because managing security at that scale will be super, super complicated. Um,
Yeah,
but
absolutely.
in
And when we think of let's use the example in the enterprise that I'm very familiar with, and probably most people are, is if we extend the analogy of an agent's like a person, um, and we think that is quite appropriate, an agent needs to be onboarded, just like a person. And when you're onboarded, you are vetted. Can you do the job? Do you have the skills and capability to the job? Once you're onboarded, you have an identity. And once you have an identity as an employee, you have an employee ID, you are given, based off of your job, you're given permissions to actually do your work. So the analogy around that is actually another one we like to bring is just as you've heard terms around HR or human resource management, we think the same disciplines, the same practices, again, within reason, can be applied to agents. Agents can be onboarded. As Davis mentioned, agents have an ID, agents have a role. We believe, to coin another phrase here, and I don't know if it's going to go too far, but just as we have HR or human resource practices, we should probably be thinking about AR or agent resource practices. Minimally, it's a good analogy, but we think it actually goes pretty far in terms of how you should think about how to protect and govern security around agents.
Yeah. Um, no, but that makes yeah. Again, it's pretty. Uh, it's a lot of new ground, right? But it makes sense. Then again, let's look into the next aspect here. Reliability. Can we it obviously ties back to security, but what's the reliability aspect of an enterprise grade agent?
Yeah, sure. I'll take this one on. Reliability, there's a bunch of different definitions, and I'll push things like trust off to the side for a moment because we will probably talk about later. So let's talk about reliability in a very specific context. When we say something is reliable, we know what what it's supposed to do. We can observe whether it did the job, and then we can fix it if it didn't do the job. So that's one aspect to it, and we think that's particularly important for agents. So not only are they discoverable and we can understand their purpose, and they can come up with task plans, but we can actually see what they did, and if they didn't do something, we can go about fixing it. The other part of reliability is it available when I expect it to be available? And in that context, this is the same disciplines we think around some of our applications that may be on the cloud or some of the SaaS applications that we may use in our organization. There's going to be service level expectations around their availability, the response time or latency. All those things are what we think should be applied to agents. Now, the interesting thing about this, you're seeing that we try and draw analogies as much as possible to things that people actually understand. The reason we do that, first off, is because they're quite appropriate, but it demystifies the whole idea around agents. And what we find is that when you put your architecture hat on to say that, the concepts are have been around for a long time. So for example, the challenges of distributed computing, which if you have lots of agents running on the cloud or elsewhere, the challenges around distributed computing, they're not easy to solve, but they are solvable. It's a known practice. Not to say that it's easy, but it's a known practice. So things around reliability, these are known practices. We believe strongly that you should be applying those practices directly to agents. Again, no different than any other enterprise application.
Yeah, no, that makes a lot of sense, but it's just yeah, the transition is difficult, right? Because it's been sitting with a few select employees, and now as you scale something as an agentic mesh, basically, you will have to multiply that and spread the knowledge of such
Hmm.
measures to more employees, or at least yeah, build the architecture such that it's scalable. That's super difficult. But we're not even halfway through. But maybe we won't take all of them. I want to leave time for questions also, if there are anyone from the participants that have questions. But let's take it the next one because it is an obvious one, right? Explainability. What? How do we make agents? Um, how do we explain them, basically?
Yeah, I can start, and then Davis, I know you have some pretty strong perspectives on this. Um, today, when you look at, I'm going to contrast with what people may be using today, Claude Code, for example, and or Codex or even ChatGPT. You can see it says thinking. And what that really is although it's not quite a task plan, it's a little bit of a loop, but it's explaining what it's doing. So you actually can see this if you use any of the modern coding tools or coding agents out there today. What we believe, if you move into the enterprise domain where agents are full participants in business processes, you need to actually have not just observability, what they did after the fact, but did they do the right thing? So when an agent comes up with a task plan, in our book, we actually recommend that that task plan is a first-class citizen in the observability sphere. It's a
Hmm.
first-class citizen in that it should be logged. And once the agent completes its task and the results of that, that should be attached somehow or linked to that task plan. And then when we look at the observability metrics, the latency or how, whether it completed successfully or not, again, is attached back to that task plan. So what ends up happening is when an agent does its work, we can see the task plan, what it thought it should be doing. We can look at the results to see how well it did, and we can look at using the observability metrics who it talked to actually complete that task. That level of explainability is not available today. We're working with some clients where we're starting to move down that particular path, but the coding agents that you're seeing today do not have that capability. The agent frameworks do not have that capability today. They can exercise parts of it, but the explainability is that end-to-end understanding what was it thinking, the task plan, how did it do, the results attached to the task plan, and the observability. Who did it talk to, whether it's tools or other agents, to actually complete that task plan? That is what it means to be a first class citizen. That gets logged so that any operability person who finds there's a problem they have to diagnose, we can actually use that in that task plan, the results, and the list of collaborators to actually diagnose the problem. When you're a developer, it gives you that information to ensure that your agent is actually tested and debugged. So there's so many uses for this explainability, which is why we think it is actually it is something that is not available easily today, but it is probably one of the single most important requirements in the enterprise today, and it is figured prominently in our book.
Yes, absolutely. Davis, did you feel like chipping in on that one, or should we move on?
Uh,
There was a
like Eric's answer was pretty great and covered a lot of the ground here. One thing that I do want to add is that you don't just need to have the plan itself tracked. What you want is for the agent to include explanations of why. You want to be able to see why the agent's doing what it's doing and include that along with the actual task plan it's executing. So you don't just see I'm planning step one, two, three. You want to see I'm doing step one, two, three for reasons X, Y, Z.
Absolutely
Yeah,
great point, Davis.
absolutely great point. Um, and I'm very thankful for the participants that have posted some questions in the Q&A. I think we should move to them in just a little bit. I just wanted to recap here. We discussed security, reliability, and explainability. Um, for enterprise grade agents, we still have scalability, discoverability, observability, and operability to uncover. But I think we should move to the questions that have been asked in the chat. I think the participants deserve to get their questions answered. And then we might follow up with a blog post or two on the data intelligence platform Substack that we have, or even our website if you feel like it. But let's definitely move to the questions in the chat or in the Q&A. I'm sorry. And I see both questions in the Q&A and in okay, I have them here. Just a second. So Ronald from Ronald Bahn, I believe, from the Netherlands. It's great to have you on this webinar. And he asks, I am interested in how to test agents and upskill or train them so that they are up to the job. Who should do this and how to do this so that you can have certified agents for certain jobs? I guess it's more high level question that addresses some of the things that we were discussing or had discussed already in detail in the previous questions. But maybe it's great to take a step back and like, can you feel I have my own definition of it, but I'm not sure I can provide a short answer to this question. But okay, let's take it again. Who should, like, I am interested in how to test agents and upskill or train them so that they are up to the job. Who should do
Yeah.
this and how to do this?
Well, let me start, and then Davis, I'm sure you have some ideas. Um, Yeah, at first blush, one would say testing an agent is the same as testing software. It is actually a very different exercise. And the fundamental reason is if I'm testing software that is deterministic, in other words, it gives you the same response given the same inputs, then simple things like an equality operator are obvious things that you use in testing. With agents, you don't necessarily have that. An agent obviously has an LLM as a brain, to use that term. But these LLMs are non-deterministic. What that really means in simple English is if I provide the same inputs twice, I may get a slightly different answer. What that means is that the traditional equality operator in testing doesn't work anymore. What you need to do is have different ways of actually evaluating an agent. So we actually think of it as a little bit more of performance management or agent evaluation as opposed to testing. So we come up with rubrics, for example, that say based on the level of autonomy and the level of criticality, obviously, if you're highly critical and you're highly autonomous, you're going to have an extremely rigorous testing and evaluation capability. And there may be 6 or 7 dimensions that dictate what you can or can't do, or have to do or not have to do. If you have something that's low criticality and low autonomy, maybe that's closer to a chatbot, I suppose. Maybe you don't need a lot of testing. So it depends on where you are in that continuum. The second thing I would say is when you're testing an agent, what we think, and I think there's terminology around this. You have an agent, a judge agent that can judge the response of another agent or a judge LLM. Those are things that we actually see out there in the field. So using an LLM to actually test an LLM, is that response, does that response, maybe it's not necessarily exactly the same or repeatable, but is the intent of the response the same? That's where we see the actual testing coming into play. We call it evaluation. Now, I'm going to ask Davis a little bit about the training side because I think Davis, there's a lot. I know you have some experience with one of our big retail clients a little while ago around how they would actually begin to try and retrain the model, and there's some challenges with that. And we came up with, back in the day, it was probably a pretty naive RAG type solution. So maybe it's not, quote, training the model, but it's equipping the model with information about your enterprise. Why don't you tell us a little bit about that? Obviously, not mentioning the client.
Yep. So there are a variety of ways you can sort of train an agent and increase its capabilities. One of them is obviously to do a sort of training of the underlying LLM, but this is a very heavyweight solution. You need a lot of examples. You need, and you need to do it for every single agent that you're going to. It simply doesn't scale. The ways to increase an agent or give it new skills that scale in a somewhat better manner are give it more data to work with or give it more tools or collaborators to handle the job. You can give it a new tool that gives it a new capability of interacting with the world by writing that capability in the tool and having the agent just include it in the task plan. You can give it additional collaborators, other agents it can contact that have capabilities your primary agent doesn't. And then it can simply call those agents and get them to do the task. Or you can effectively provide the agent with more data. You could do a relatively naive route. You could do some more advanced solutions like knowledge graphs, things like that to get more information. And this lets the AI make better decisions because it has more information available. And these are the main ways you're going to sort of train or upskill an agent that scales to the thousands and thousands of agents we're eventually expecting to have.
Yeah, now I want to address the last part of Ronald's question around certification because we actually dedicate an entire chapter to this. It's part of our trust framework. So again, forgive me, I'm going to use another analogy. In Canada, and I suspect it's the same in Europe, but when I pick up my toaster in Canada, I get a little logo at the bottom of it that's called the Canadian Standards Association. What it says is my toaster is not going to burn my house down when I use it. What it says is that that brand means there's a level of service expectation, quality around that. That label means that that toaster is certified. In the United States, they have Underwriters Lab that does the same thing. In Europe, I'm not sure, but in Canada, again, if I look at a power outlet, I can see a little logo that says this power outlet is safe to use. We think that same idea applies to agents. And we think it is the top level of that governance stack, the trust stack, actually. It starts with identity and roles, moves up to explainability, but fundamentally at the top of the house, what we have is certification and governance. What we believe strongly is that there are models out there today, like Canadian Standards Association, Underwriters Lab, they're federated governance models, federated certification models that every single day are able to certify that literally millions, hundreds of millions of products are safe to use. We believe that same idea can apply to agents. So we believe the model again is laid out for us. It is there that has, among other things, it has a completely delegated framework that says I have macro level policies that need to adhere to, and then they go down into for electrical specifications for a toaster to heating specifications, metal for the container of the toaster. All those things have a federated specification framework and a federated governance framework and accredited institutions. Now, that sounds very, very complicated. Okay. And if you're managing hundreds of millions of products, maybe it should be. But inside the enterprise, this model works also. So at the top level, we may say, for example, that an agent must be GDPR compliant. That one then delegates to an identity verification agent, and you come up with implications on how that identity verification agent would be GDPR compliant. You'd apply that to all the other agents also. So maybe what we should have is a set of specifications, again, broken down into particularly probably by business domain at a granular level. And then what we have is those specifications have experts who can actually validate that specification and that using the explainability approach that we mentioned earlier, that agent actually adheres to that specification. We believe that model, metaphorically, will ensure that your agent doesn't burn down your data center house. So we see a lot of examples and analogies that will simplify an enterprise's agentic journey, and they're standing right in front of us, Ole.
Yeah, no, that makes sense. I mean, it's really about taking some surprisingly concrete uh, perspectives from the existing world and just uh, applying them in an agentic reality, quite simply. Um, and I can see also, Ronald, thank you for getting back to us and that the answer was complete. We also have questions from Michael and from Sabrina. Hi, both of you. It's great to have you on the webinar. Michael, I'll go first. I can see you posted first, but I did see your question also, Sabrina. So Michael writes, curious to understand participant perspectives on the impacts of business-defined semantic layer to AI service providers, specifically unlike that of Epic EHR health system or SAP ERP platform that generally force their clients to adopt much of their workflows, user roles, etc., and compare that to what it means to have a business-defined agentic architecture. How to anticipate AI services providers, OpenAI and Anthropic, can scale their businesses if their clients will need their own uniquely defined semantic layer. I get the
Yeah.
question. Can you follow it, or is it too
Yeah,
long?
no, I'm reading it actually. I have it sitting in front of me on the screen. First off, Michael, that is a fantastic question. And I think the timing is so appropriate for a number of different reasons. Now, I am not an expert in the data catalog or semantic space. Ole probably is. But let me tell you, I do run into it and I do have a perspective because we see it in almost every client engagement that we work with. So let me take the step back from some simple basics. When an agent tries to respond to a request, as Davis mentioned, we load information about that business or about that topic as close as possible to that request so that the agent has all the information available to it. That's called, context engineering, where we want to find the right context at the right time for the right token budget and put that into the agent context window so it can most effectively do its job. Here's the challenge is in a enterprise that has hundreds of terabytes or petabytes of information, a corpus, whether it's structured data, unstructured data, images, video, there's petabytes of that stuff out there. How do I get the right information from those petabytes and I get it to what is effectively anywhere from 200,000 to a million tokens, a token being about a word, just to make it real. So how do I do that? Well, what we find is in order to do that well, this is what we call you need to have an agentic knowledge fabric. Fancy word of saying I need to be able to I need to have a virtual context manager that creates the minimum, I emphasize minimum because there's a token budget, viable, which means it has concepts and policies, decision boundaries, and I can put that into the agents or the LLM's context window. In order to do that, you could use a bunch of different approaches. Technically, you can do a naive reg. As Dave has mentioned, it probably doesn't work very well necessarily. You could augment that with knowledge graphs. There's a variety of different things. We've talked to some clients who are using things like PageRank to actually understand and link the concepts in a very large, vast graph. Fundamentally, that's a mechanism that you need to think about. But the way you make sense of it is through taxonomies and ontologies. What are the concepts that I should be capturing? How do I actually represent a policy in a knowledge graph? How do I actually manifest the relationships between these policies that may apply to a customer in the AML sense, anti-money laundering sense, which is different than a customer from a sales perspective? The attributes are very, very different. So these are all things that you need to think about. And we call it this agentic knowledge fabric that has underneath it, like I said, a knowledge graph, an ontology, some taxonomy capabilities. But ultimately, what you need is semantic consistency, semantic coherence, so you can give the right information, the right time, the right token budget to the agent, the LLM. We see semantic understanding, taxonomies, ontologies, all sitting on top of this knowledge fabric as the next innovation within the agent landscape.
That is certainly also something that I am following very, very closely and thinking about. And obviously, this webinar is not about Action as a company. So for respect of the participants, I don't think I should go into it here. But that is, I think, very precisely defined and one of the challenges that will have to be solved and in the coming time, right? We have a question also from Sabrina, and I saw your question, Sabrina, so I want to just go ahead and ask it. Oh, well, actually, it's also a little bit about testing. So to the extent, uh, let me go ahead and ask it, but I actually think you have answered it. Can you see it also, Eric and Davis?
Yeah, I
It's
can,
in
I just
Yes, I
looked
can
at
see
it in
it.
yeah, I saw it in the webinar chat. Yeah, I can see it.
What's your? Maybe we should. Davis, did you have anything you wanted to chip in about this question? You
Uh,
see it?
I think a lot of it was covered in the previous answer, but it might be worth going over some of the points again. Um, One of the first things mentioned is who should be writing the tests. Should these be written by agents, by humans, or both? And this is largely going to depend on how mature your agentic mesh is. At the early stage, when you're building your first agent, your first even few dozen agents, it makes sense that most of your testing should be done by people. You're still getting the hang of agents, so you're going to want manual evaluation. But as the agentic mesh grows, as you get thousands and tens of thousands or more agents, you're going to have to start relying more on effectively agents testing agents simply to manage at the scale needed where you don't have enough people to manually check every single output every single time. You're not going to completely get rid of human testing. You're going to still need humans to go in and verify that the tests are actually correct, to do spot checks, make sure nothing's gone wrong. But how much is human or agent will depend on how mature you are in developing your own agentic mesh.
Yeah, Davis, one of the
Yes.
things we talked about is, and I know we had great debates with some of the other folks in our company and some clients, but when you think of the high autonomy and high criticality, there's a discussion that says that for some of those very highly autonomous and highly critical, in other words, high risk scenarios, that today at least, maybe this will change in the future, but in the foreseeable future, we think those there's a subset that must have human interaction and must have human verification. Things related to health, for example. Maybe high value payments, for example, where there may be some fraud exposure or anti-money laundering. There's a subset of the testing that we think for the foreseeable future needs to remain, or at least have that human in the loop or the human above the loop explicitly.
Yeah. Um, I think I will, as we're approaching the end, I think I would like to ask the final question that I had prepared, and we can get back to the remaining discussion topics in posts. But I do want to ask you, um, what was it like writing this book? Uh, because I guess all books, they you have a certain feeling about them. They can be too early, they can be spot on, they can be too late. You can get different kind of reactions. Like what has been the feedback so far? Are you too early? Are you too? I guess you're not too late.
Well, yeah, well, let me start and then I'll let Davis answer what it was like working with his father, I suppose. Uh, here's what I would say is when Davis and I came up with the idea for this book, it was Ole knows this, written a few books with O'Reilly. There's a long process. So this is about 14 to 16 months ago where we didn't know how the agent landscape was going to evolve. There was no such thing as Claude Code or Codex, and ChatGPT was still at version 3.5 or something like that. Not very effective, to be honest with, at least not compared to today. It was wonderful back in the day, but compared to today, it wasn't really where it needs to be. Interestingly enough, we looked at analogies. What happened in the enterprise when you had went from one to many? So back in the day, I did a lot of work with APIs, and when you have one or two or three APIs, which is very a long time ago, it's easy to manage them. But when you have 10, 100, or 1,000 APIs, you need to think very differently. Same thing with data products. If you have one or two data products, that's interesting. But when you have 10, 100, more than 100, like some of my clients do, you're talking about a different way of thinking about it. You have to think about different management practices. So when Davis and I came up with the idea for this book, and when we pitched it to O'Reilly, that was the argument where we're not going to stop with one agent. We're going to have, tens, hundreds, thousands, and the industry leaders have confirmed that. So a long-winded answer, Ole, is we think we're at the right time, at the right place, which we didn't know 16 months ago, but we're fortunate to be there right now.
Well, yeah, that's kind of my feeling as well. Davis, do you want to chip in? I want to hear the details about writing with your father.
Yeah, no, writing with my father was a great experience. We've obviously known each other a lot. It lets us get in the same wavelength when we're talking about our ideas. Um, it was, however, quite a bit different than the usual consulting work we do together, especially because my father has a lot more experience writing books than I had at the start of this. And I'm
Yeah,
quite glad I was writing the book with someone who had that experience, as it proved quite helpful in getting the book up to the high standards we set for ourselves.
yeah, no, that makes a lot of sense. I mean, it is also, and like, really, really, it's just a really, really different experience writing with someone else and writing a book for the first time. But I feel also like if I have to say something about timing of your book, I think it's at the right moment in time because it's not like everyone kind of sees this now. They see that we need to think about building agentic architectures in our company, and we can understand also that this is not something that you can that you can take lightly. It will be complicated to set this up, right? So I think the book is very timely and it's super interesting read. So I guess with these words, I want to thank you for participating in this webinar here today. And we will be back with more insights in shared posts and writings. I can guarantee that you are at least most welcome to write for us, and I would be happy to write with you also. I also want to thank all the participants for patience. This was, I guess, a slightly technical webinar, but very needed also. So thank you everyone for listening in. And thank you, Eric and Davis.
Well, Ole,
Thank you
thank
as
you very
well.
much to you and the whole Actian team for having us. Thank you very much.
And I say thank you as well. It was great to be on.
Thank you.